The night has finally come to claim the world, wrapping the noise of the day in a heavy velvet blanket of silence. It is time to let go. Allow your eyelids to grow heavy, heavier than they have been all day, as if gravity itself is gently pulling them down to meet your cheeks. There is nothing left to solve, nothing left to organise, and nowhere else you need to be. You're safe here, in this sanctuary of stillness, suspended in the quiet space between waking and sleeping. Take a deep, slow breath, inhaling the cool tranquility of the shadows, and as you exhale, imagine the tension leaving your body like mist evaporating off a morning lake. Your shoulders drop, your jaw unclenches, the muscles in your back soften, sinking deeper into the mattress, melting into the support beneath you. As you lie here, fully supported and weightless, imagine that the ceiling above you begins to dissolve. It fades away, not into nothingness, but into the infinite depth of the cosmos. The walls of your room expand outwards, further and further, until you're no longer enclosed by brick or wood, but embraced by the vast, silent cathedral of space. The air around you is cool and crisp, yet you feel a profound warmth within, a glowing ember of consciousness drifting upward. You're rising now, slowly, effortlessly, lifting off the surface of the earth. The lights of the cities below, the street lamps, the glowing windows, the headlights of cars, begin to shrink, turning into tiny glittering constellations of their own, before fading into the dark curvature of the planet. You are floating free, untethered, a traveller of the dreamscape, drifting toward a river of light that stretches across the canopy of the universe. We're going on a journey tonight, a slow and majestic voyage through our celestial home. We're not just observing the stars, we're floating among them, bathing in their ancient glow. Here, time behaves differently. It stretches and loops, moving as slowly as a glacier, allowing us to examine the wonders of creation without haste. There is no rush to reach a destination, for the journey itself is the destination. So let yourself drift. Let your mind wander into the shimmering expanse. Let the starlight wash over you, cleansing your thoughts as we begin to explore the magnificent spiralling city of stars that we call home. High above the earth, looking out into the obsidian depths, the first thing that captures your gaze is a band of luminosity that seems to split the sky in two. It looks like a spilled fluid, a ghostly stream of diamond dust poured by a giant hand across the firmament. For thousands of years, civilizations gazed up at this hazy arch and saw a river. The ancients whispered that it was milk spilled from the breast of a goddess, a nourishing fluid that gave life to the heavens. This poetic imagery gave our galaxy its name, a title that evokes softness, sustenance, and a fluid grace. Visualize this band not as a static painting, but as a flowing current of light. It is composed of the collective glow of countless stars, so distant and so numerous that your eyes cannot distinguish them individually. Instead, they blend together into this creamy, pearlescent stream. As you float closer, you can see the texture of this river. It is not uniform. It is mottled with dark patches, rifts in the light where great clouds of interstellar dust obscure the brilliance behind them. These dark lanes create a sensation of depth, of valleys and mountains sculpted from shadow and radiance. The Greeks called it the Galaxias, the Milky Circle, a road of souls or a pathway for the gods. As you drift alongside this luminous avenue, you can feel the ancient awe it inspired, a sense of belonging to something vast and nurturing, a cosmic stream that flows through the night, carrying the dreams of every creature that has ever looked up. As we continue to drift, pulling back to view this river from a greater distance, the sheer scale of the structure begins to unveil itself. It is difficult for the human mind to comprehend true vastness, but try to picture a beam of light. Light is the fastest traveller in the universe, a messenger that can circle the Earth 7 times in a single heartbeat. Now, imagine that beam of light starting at one edge of our galaxy, setting off on a journey to reach the other side. It travels through the vacuum, past nebulae and star clusters, rushing at supreme speed. It would not reach the other side in a year, or a century, or even a millennium. That beam of light would have to travel for 100,000 years to cross from one rim to the other. That is the breadth of the stage we are floating upon. It is a distance that renders our daily worries microscopic. Visualize this expanse as a sprawling, shimmering city of light, a disk so wide that civilization could rise and fall 1,000 times over before a signal could cross its diameter. You're floating in a structure of such immense proportions that it essentially functions as its own universe, a boundless container of possibilities. Feel the comfort in this size. In a place this large, there is room for everything, space enough to lose yourself completely, drifting in the void between the edges of the unimaginable. From this high vantage point, seeing the galaxy in its entirety, you begin to perceive its true shape. It is not merely a shapeless cloud or a simple swirl. It possesses a grand geometric elegance. Picture a flat, spinning disk, like a potter's wheel thrown into the heavens. But as you look closer at the centre, you see a distinct, straight structure. A bar of bright stars cutting through the core. We do not live in a simple spiral. We inhabit a barred spiral, a magnificent pinwheel with a glowing baton at its heart. From the ends of this central bar, great arms of starlight unfurl, curling outwards in graceful logarithmic arcs. Imagine these arms as ribbons of light trailing from a dancer's spinning form. They are not solid, they are waves of density, traffic jams of gravity where stars and gas are compressed until they ignite. You can see the distinct blue tint in these spiral arms, the signature of young hot stars burning with ferocious intensity. Contrasting this is the golden yellow glow of the centre, where older, cooler stars reside. The galaxy looks like a firework frozen in mid-explosion, a celestial flower with petals of diamond and sapphire unfurling into the dark. Watch it spin in your mind's eye, a slow, hypnotic rotation that has continued for eons, a cosmic mandala turning in the silence of the void. Now, let us descend from the high view and drift downwards into the intricate lattice of one of these spiral arms. We are looking for a specific place, a home within the home. We do not reside in the frantic, crowded centre of the city, nor do we live in the desolate, lonely outskirts. We are situated in what could be called the galactic suburbs, a quiet, stable neighbourhood known as the Orion Arm, or sometimes the Orion Spur. Visualize this location as a calm eddy in a rushing river. It is a minor arm, a bridge of stars located between two major spiral arms, tucked away in a relatively peaceful pocket of space. This location is fortuitous. It is far enough from the dangerous radiation and gravitational chaos of the core, yet rich enough in heavy elements to build planets and life. Picture our sun as just one gentle porchlight in this quiet cul-de-sac. Being here allows us to gaze out into the universe with a clear view, unblocked by the dense fog of the galactic centre. Feel the safety of this positioning. We are tucked away in a Goldilocks zone of the galaxy itself, a sanctuary of stability where life could flourish undisturbed for billions of years, cradled in the gentle curve of the Orion Spur. Leaving our quiet neighbourhood, we allow our consciousness to be pulled inward, drawn by an irresistible force toward the bright, mysterious heart of the galaxy. As we approach the centre, the stars become thicker, packed tighter together. The night sky here would not be dark. It would be ablaze with the light of 1,000,000 suns, a dazzling, blinding brilliance. But deep within this crowded ball of light, exactly at the centre of the galactic rotation, lies a region of profound darkness and immense power. Here lies the great anchor of our galaxy, a supermassive object known as Sagittarius A. Visualize a point of gravity so intense, so absolute, that it curves the fabric of space around it like a heavy stone sitting on a taut sheet. This is a black hole, a sleeping giant 4 million times the mass of our own sun. But do not fear it. In this dream, you are an observer, safe and untouched. See it not as a monster, but as the hub of a great wheel. It is the invisible conductor of a symphony, its gravity orchestrating the dance of stars that whip around it at incredible speeds. Around this dark heart, swirls of gas glow in violet and ultraviolet, heating up as they spiral in. It is a place of ultimate contrast, the brightest matter dancing on the edge of the deepest dark, a silent, majestic engine that has held the galaxy together since the dawn of time. As we linger near this ancient core, we begin to contemplate the concept of age. The structure you are visualizing is not new. It is a relic of the early universe. Our galaxy is nearly as old as the cosmos itself. Picture a timeline stretching back into the foggy mists of eternity. The universe came into being, and shortly after, mere moments in cosmic time, the first seeds of the Milky Way began to coalesce. We are looking at an object that is approximately 13.6 billion years old. It has witnessed almost everything that has ever happened in the history of existence. Visualize the first wisps of hydrogen and helium pulling together in the primordial dark, lighting the first fires. Over eons, it cannibalized smaller clouds and dwarf galaxies, growing larger layer by layer, like a pearl forming around a grain of sand. It is a grandmother to the stars, a witness to the birth and death of solar systems long before our own sun ever ignited. Feel the weight of that history, a slow, deep, resonating hum of survival and persistence. To float within the Milky Way is to float within a living museum of the universe's history, touched by the ancient hands of creation. Drifting outward from the ancient core, we find ourselves surrounded by the population of this stellar city. The sheer number of inhabitants is staggering. Try to visualize a sandy beach, stretching for miles, golden and glistening in the sun. If you were to pick up a handful of sand, watching the thousands of grains slip through your fingers, you would still not be holding enough grains to represent the stars in our galaxy. Estimates suggest there are between 100 billion and 400 billion stars spinning in this disk. Imagine each star as a story, a world, a potential sun to a system of planets. Some are red dwarfs, small, cool and dim, glowing like dying embers for trillions of years. Others are blue giants, massive and volatile, burning through their fuel with reckless abandon. There are pulsars acting as cosmic lighthouses, and white dwarfs cooling slowly into crystal. As you float through this sea of lights, realize that you are never alone. You're surrounded by a crowd of billions, a silent community of nuclear furnaces illuminating the void. The abundance is overwhelming, yet comforting, a testament to nature's boundless capacity for creation. Everything in this vast city is in motion. We tend to think of the ground beneath our feet as still and the stars above as fixed points. But this is an illusion of our short lifespans. In reality, the entire galaxy is spinning like a great cosmic carousel. Feel the sensation of this movement, a smooth, frictionless glide through the ether. Our own solar system, caught in the flow of the Orion Arm, is travelling at an astonishing speed of nearly 500,000 miles per hour. Yet, the galaxy is so vast that even at this speed, it takes a monumental amount of time to complete one single orbit. We call this a galactic year. It takes approximately 230 million terrestrial years for our Sun to make one full circle around the galactic centre. Visualize where the Earth was one galactic year ago. Humans did not exist. The continents were in different places. The dinosaurs were just beginning their rise to dominance. The last time we were in this exact spot in the galaxy, the world was a lush, prehistoric jungle. We are travellers on a long, slow orbit, a journey that spans geological eras, moving in a grand, circular rhythm that marks the passage of deep time. But what holds this spinning carousel together? If we look only at the stars and the gas, the visible matter, there isn't enough gravity to keep the galaxy from flying apart. The outer stars are moving too fast. They should be flung out into the void like water droplets from a spinning tyre. There is a presence here, something unseen, a ghost in the machine. We call it the dark matter halo. Visualize an invisible sphere, a vast transparent cocoon that encases the entire flat disk of the galaxy. This halo extends far beyond the visible edge of the stars. It is the unseen scaffolding, the gravitational glue that binds the galaxy together. We cannot see it, touch it, or interact with it. Yet we know it is there by the way it cradles the stars. Imagine floating in a glass sphere, where the glass is invisible but strong, holding the snow of a snow globe in suspension. This dark matter makes up the vast majority of the galaxy's mass. It is a comforting thought that the greater part of our reality is a silent, invisible guardian, a force that ensures the stars remain in their lanes, dancing their eternal waltz without faltering. As we drift to the very edge of this invisible halo, gazing out into the deep intergalactic void, we notice that the Milky Way is not entirely alone. Like a great ship accompanied by smaller vessels, our galaxy has companions. These are the satellite galaxies, the most famous of which are the large and small Magellanic Clouds. Visualize them as glowing, irregular clouds of light, hovering nearby, tethered to us by invisible strings of gravity. They look like detached pieces of the Milky Way, fragments that have drifted off but cannot bear to leave. If you were standing in the southern hemisphere of Earth, looking up on a clear night, they would appear as smudge marks on the sky, glowing soft and pale. These dwarf galaxies are dancing with us, slowly orbiting our massive shape, occasionally dipping through the disk of the Milky Way, leaving trails of gas and stars in their wake. They are our celestial neighbours, reminding us that even in the vast loneliness of the universe, there is company, a gravitational family travelling together through the endless dark. As we gaze past our smaller satellite companions, peering deeper into the black velvet abyss, we become aware of a presence much larger, a majestic mirror to our own home. Floating in the distance, shining with the collective light of 1 trillion stars, is the great Andromeda Galaxy. Visualize it as a sister spiraling in the dark, a grand, luminous pinwheel angled slightly against the void. It is the only object in the universe that you can see with your naked eye that is not part of our own galaxy. A faint smudge of ancient light that travelled through the emptiness long before humans walked the earth. There is a slow, cosmic dance occurring between us and this great sister. While the rest of the universe expands, drifting apart like leaves on a widening pond, the Milky Way and Andromeda are falling toward one another. Do not imagine a collision of violence or destruction, but rather a graceful merging of ghosts. They are drawn together by the irresistible tether of gravity, moving at a speed that seems fast to us, but is glacially slow in the theatre of the stars. In the deep future, eons from now, these two great spirals will meet, passing through one another like clouds of smoke, their stars mixing into a new, greater elliptical haven. It is a destiny written in gravity, a promise of union that spans the ages, reminding us that even galaxies seek connection in the vastness of the night. Zooming out further, allowing our perspective to widen until galaxies appear as mere islands of light, we realise that we are part of a cosmic archipelago. Our galaxy, Andromeda, and the smaller Magellanic Clouds are not drifting alone. We are members of a distinguished family known as the Local Group. Picture a quiet village in the countryside of the universe, a cluster of over 50 galaxies bound together by their mutual gravitational embrace. In this visualization, space is not empty. It is a web of influence. Most of these galaxies are small, dwarf elliptical galaxies, hovering like moths around the bright lanterns of the Milky Way and Andromeda. We are the heavyweights, the anchors of this celestial clan. There is a profound sense of community here in the deep vacuum. Even across distances that light takes millions of years to traverse, we are tied to our neighbours. We move together, a huddled collection of civilizations and stars drifting through the darker, emptier expanses of the cosmos as one cohesive unit, protected by the gravity that binds us. Yet, even this local group is but a speck in a much grander design. As we continue to drift outward, the scale shifts again, becoming almost too large for the mind to hold. We are flowing within a river of galaxies, a titanic supercluster known by the Hawaiian name Laniakea, which means immeasurable heaven. Visualize a flowing watershed where thousands of galaxies are streaming like droplets of water, all sliding down invisible gravitational valleys toward a mysterious focal point. We are on the fringe of this great structure, a feathery tendril of light in a web that stretches across hundreds of millions of light years. To picture Laniakea is to picture the neural network of a giant mind, or the branching roots of an ancient tree, with our entire Milky Way being just a single glowing cell on one tip of a root. We are flowing toward a region known as the Great Attractor, a gravitational anomaly that pulls us gently, steadily, guiding the motion of our entire galactic neighbourhood. Feel the comfort of this flow. We are not aimless wanderers. We are part of a grand current, a majestic procession of galaxies moving in unison through the veins of the universe. Let us now gently contract our view, floating back down from the supercluster, back into the familiar embrace of the Milky Way itself. As we return, we notice something peculiar about the shape of our home. From a great distance, we idealized it as a perfect flat disk, like a dinner plate spinning on a table. But as we drift closer to the edge, we see that the galaxy is not perfectly flat. It possesses a gentle rhythmic distortion known as the galactic warp. Visualize an old vinyl record that has been left in the warmth of the sun, its edges curling slightly upward on one side and dipping downward on the other. This is the true shape of our galaxy. The disk bends in a subtle S shape, a response to the gravitational tug-of-war with our satellite neighbours. It is as if the galaxy is billowing like a skirt in a slow breeze, or a brim of a hat pulled down over one eye. This warp shows us that the Milky Way is flexible, dynamic, and responsive. It is not a rigid structure of stone, but a fluid body of light, reacting to the environment around it, rippling softly as it spins through the dark. Moving inward from the warped edges, we enter the space between the stars. We often think of space as a total vacuum, a nothingness. But here in the galaxy, the space is alive with a subtle substance called the interstellar medium. Picture a mist, so fine and tenuous that you could walk through it without ever feeling it against your skin, yet vast enough to weigh more than millions of suns. This is the atmosphere of the galaxy, a cocktail of gas and microscopic dust grains drifting in the silence. This medium is the breath of the Milky Way. It is composed mostly of hydrogen, the most ancient element waiting in the dark. But mixed within it are tiny crystals of ice, silicates, and carbon, the very building blocks of worlds. If you could taste this cosmic fog, astronomers believe the centre of the galaxy might taste like raspberries and smell like rum, owing to the specific chemical compounds floating there. Visualize yourself drifting through this tenuous fog, the starlight filtering through it like high beams cutting through a morning mist. It is this medium that connects every star system, a galactic soil from which new stars will eventually bloom. As we drift deeper into this interstellar mist, we come upon a region where the gas has thickened, clumping together into magnificent glowing clouds. These are the nebulae, the nurseries of the stars. Visualize a landscape of towering pillars and canyons, not made of rock, but of glowing gas, illuminated from within by the fierce light of newborn suns. These are the most colourful places in the galaxy, painted in hues of deep crimson, shocking pink and vibrant teal. Imagine floating near the Great Orion Nebula, a cavern of light where the gas is so dense it collapses under its own weight. In the heart of these clouds, gravity is knitting the gas together, spinning it faster and faster until it ignites. You're witnessing the moment of conception for solar systems. All around you, baby stars are flickering into existence, casting off their dusty cocoons and sending ultraviolet winds rushing through the cloud, carving out sculptures in the vapour. It is a place of violent creation, yet from our vantage point, it appears as a silent glowing masterpiece, a frozen explosion of colour where the galaxy renews itself. Not all nebulae glow with their own light. As we drift away from the stellar nursery, we encounter a different kind of cloud, a silhouette against the starry background. These are the dark nebulae, the shadow makers of the Milky Way. Visualize a dense, inky patch of smoke drifting in front of a bright fire. These clouds are so thick with interstellar dust that they block the light of the stars behind them, creating holes in the sky that look like portals to an infinite void. The most famous of these is the Horsehead Nebula, standing like a dark chess piece against a curtain of red light. These regions are cold, quiet, and mysterious. They are the sleeping chambers of the galaxy, molecular clouds where the temperature drops to near absolute zero. In these dark, silent wombs, the seeds of future stars are protected from the harsh radiation of the outside universe. There is a profound peace in these shadows, a reminder that even in a galaxy of 1 billion lights, there is a necessary place for darkness, for rest, and for the quiet accumulation of potential. Leaving the dusty plain of the galaxy, we float upwards, hovering above the main disk. Here, orbiting the galactic centre like bees swarming a hive, we find the globular clusters. These are the ancient cities of the Milky Way. While the spiral arms are full of young chaotic stars, these clusters are spherical balls of light, packed tight with hundreds of thousands of very old stars. Visualize a jewellery box where diamonds have been poured into a pile, resting against black velvet. The stars here are so close together that if you lived on a planet inside a globular cluster, the night sky would never be dark. It would be washed in the eternal twilight of 1,000 full moons. These clusters are the survivors, remnants from the very formation of the galaxy. They have circled the core for billions of years, stable and enduring. There is a sense of timelessness here, a preservation of the ancient light, holding the memories of the galaxy's infancy within their tightly bound gravitational embrace. Drifting back down into the spiral arms, we encounter a different kind of family, the open clusters. Unlike the ancient spherical globular clusters, these are loose, irregular gatherings of young siblings. These stars were born from the same nebula, formed from the same cloud of gas, and are now drifting together through space for a brief cosmic summer before they disperse. The most famous of these is the Pleiades, the Seven Sisters, glowing with a fierce icy blue light. Visualize them as a handful of sapphires cast onto a dark table. Wisps of the nebula that birthed them still cling to their sides, reflecting their blue radiance like a sheer veil. These stars are energetic and bright, living their lives in the fast lane. Floating among them, you feel the vitality of youth, the raw energy of stars that have only just begun their journey. Over time, the gravity of the galaxy will gently pull them apart, sending them off to travel alone. But for now, they shine together, a beacon of blue fire in the dark. Finally, we turn our attention to the very substance that makes up your own body, and the connection it holds to this galactic cycle. Every atom in your blood, the calcium in your bones, the carbon in your mind, all of it was forged in the hearts of these stars we have been observing. The galaxy is not just a place you live, it is the ancestor that created you. This process is known as galactic recycling. When the massive stars in the spiral arms reach the end of their lives, they do not simply fade, they surrender their material back to the universe. Visualize a supernova, a star bowing out in a flash of brilliance that outshines the entire galaxy for a few weeks. In this explosion, it creates gold, silver, iron, and oxygen, blasting these precious elements out into the interstellar medium. This enriched dust mixes with the gas clouds, cooling and condensing to form new stars, new planets, and eventually, life. We are currently floating in a great cosmic ecosystem, a cycle of death and rebirth where nothing is ever truly lost, only transformed. You are, in the most literal sense, stardust that has gained consciousness, looking back at the garden that grew you, intimately connected to the flow of the Milky Way. Deep within this cycle of stardust and transformation, let us become aware of our own specific trajectory through the heavens. We often imagine that we are simply circling the centre of the galaxy in a perfect flat loop, like a horse on a carousel. But the reality of our motion is far more dynamic and purposeful. We're not merely circling, we're travelling toward a destination. Visualize the sun not as a stationary anchor, but as a ship sailing through the interstellar sea, with all the planets, including Earth, trailing in its wake. We're moving at a tremendous speed toward a specific point in the sky, located near the constellation of Hercules. This direction is known as the solar apex. Imagine standing on the prow of this great solar ship, feeling the wind of the galaxy against your face. This wind is the interstellar medium rushing past us as we plough through it, creating a bow shock much like water piling up before the nose of a boat. The magnetic bubble of our solar system pushes against the gas of the galaxy, creating a protective shield that trails behind us like a comet's tail. Feel the sensation of this forward momentum, a confident, steady drive through the stars. We are not lost. We're heading somewhere, guided by the grand momentum of our birth, sailing forever into the fresh waters of the cosmos. As we sail forward, riding this bow wave of the sun, we might feel a sense of disorientation regarding up and down. On Earth, we are grounded by the horizon, but here in the velvet suspension of space, the angles are entirely different. If you were to look at the plane of our solar system, the flat disk where Earth and the other planets orbit, and compare it to the plane of the Milky Way, you would see that they do not match. We are tipped. Visualize a great dinner plate spinning in the dark. That is the galaxy. Now imagine a smaller saucer, our solar system, floating near it. The saucer is not lying flat. It is tilted at a steep 60-degree angle relative to the galactic table. This means that as we look up into the night sky from Earth, we are actually lying on our sides relative to the galaxy. The Milky Way does not cut across our sky perfectly overhead. It slants, a glowing sash worn diagonally across the night. This tilt suggests a tumultuous history, a hint that our solar system may have been knocked askew eons ago by passing stars or gravitational tides. Let this angle be a reminder of our unique perspective. We are reclining travellers, leaning back as we gaze into the centre, viewing the majesty of our home from a distinct, jaunty angle that is ours alone. From this tilted vantage point, if you look toward the centre of the galaxy on a clear dark night, you will see something that looks like a tear in the fabric of the sky. This is the Great Rift. To the indigenous peoples of the Southern Hemisphere, this was not emptiness. It was a physical feature, a dark river or a celestial emu etched against the background of stars. Visualize a long, jagged scar of darkness running lengthwise through the brightest part of the Milky Way. It looks as though someone has drawn a heavy curtain across the centre of the stage. This is not an absence of stars, but an abundance of dust. You're looking at a massive overlap of molecular clouds, a wall of cold material so thick that it blocks the blazing light of the galactic core behind it. Imagine standing at the foot of a colossal mountain range at night, where you cannot see the mountains themselves, but you can see where they block out the stars. That is the Great Rift. It creates a sense of profound depth. You're seeing the foreground shadows against the background fire. It is a reminder that the galaxy is not just light, it is texture, layer upon layer of smoke and brilliance, a landscape of valleys and ridges made of shadow. Hidden within these shadows and the spaces between the stars are wanderers that defy the standard definition of a solar system. These are the rogue planets. We are accustomed to planets huddling for warmth around their parent stars, obediently following their orbits. But out here in the deep dark, there are worlds that belong to no sun. Visualize a planet the size of Jupiter, or perhaps Earth, drifting entirely alone through the obsidian void. These nomads may have been ejected from their birth systems billions of years ago, flung out by a gravitational slingshot to wander the galaxy in solitude. It might seem lonely, but picture them instead as peaceful travellers. Without a nearby sun to scour them with radiation, they drift in an eternal quiet night. Some may still be warm from within, their cores glowing with volcanic heat, perhaps sheltering oceans beneath thick shells of ice. They are the silent monks of the Milky Way, untethered and free, moving through the silence without a calendar, without a year, without a dawn. They remind us that one does not need a center to exist. One can simply be, drifting with grace through the infinite. This freedom is beautiful, yet we are fortunate to be where we are. As we survey the geography of the galaxy, we come to understand that there are safe zones and danger zones. We reside in what astronomers call the galactic habitable zone. Much like a solar system has a Goldilocks zone where water can exist as a liquid, the galaxy itself has a ring of life. Visualize the galaxy as a great city. The center is too crowded, filled with high radiation, exploding stars, and the dangerous gravity of the supermassive black hole. It is a place of chaos. The far outskirts, conversely, are too desolate. They lack the heavy elements, the metals and rocks needed to build solid planets. But we are in the suburbs, the perfect middle ground. Visualize a ring-shaped band located about 26,000 light-years from the center. Here, the stars are spaced comfortably apart. The radiation levels are low, allowing atmospheres to remain thick and protective. The chemistry is rich, filled with the ingredients for life. Feel a sense of gratitude for this cosmic real estate. We are nestled in the most serene, fertile valley of the Milky Way, a sanctuary designed by physics to cradle fragile things like oceans, forests, and us. But even in this quiet zone, the sky carries the ghosts of the past. If we look closely at the movements of certain groups of stars, we can see that they are not moving randomly, but flowing together like schools of fish. These are the stellar streams. Visualize long, winding ribbons of stars wrapping around the galaxy, threading through the disk like embroidery. These streams are the skeletal remains of smaller dwarf galaxies that the Milky Way has consumed and pulled apart over billions of years. When a small galaxy gets too close to us, our gravity unravels it, stretching it out into a long line of stars that continues to orbit the core. The Helmi stream is one such ribbon, a river of stars that once belonged to a different home, now adopted into ours. Seeing these streams is like reading the ancestry of the Milky Way. It is a record of assimilation, a beautiful flowing scar that tells the story of how our galaxy grew to its current majesty. It reminds us that nothing disappears. It merely changes form, becoming a new current in the great galactic ocean. Drifting away from these ghostly rivers, we turn our attention to the sheer vertical scale of the galaxy. We have visualized it as a flat disk, but flat is relative. The structure is actually divided into two distinct layers, the thin disk and the thick disk. Imagine a pancake floating in the air. This is the thin disk where we live. It contains most of the gas, the dust, and the young bright stars. It is the bustling, chaotic marketplace of the galaxy. But enclosing this pancake is a puffier, wider layer, the thick disk. Visualize a halo of older, wiser stars that rise high above and dip far below the main plane. These stars are the elders of the galaxy. They move on strange, bobbing orbits that take them high up for a panoramic view of the spiral arms, then plunge them back down through the center. The thick disk is like a protective atmosphere of stars, a diffuse glow that softens the hard edges of the spiral. It adds volume to our home, turning it from a simple 2D shape into a complex, breathing 3D structure with a distinct upper and lower atmosphere of ancient light. Among these billions of stars, both young and old, there is a particular type of light that dominates the population, though we rarely speak of it. We tend to focus on the bright, blazing suns like our own, or the massive blue giants. But the true citizens of the Milky Way are the red dwarfs. Visualize a star much smaller than the sun, perhaps only a fraction of its size, glowing with a soft, deep crimson light. It is not blinding, it is warm, steady, and dim, like a dying ember in a fireplace. These red dwarfs make up nearly 75% of all the stars in our galaxy. If you were to take a random survey of our neighbours, almost all of them would be these small red lanterns. Because they burn their fuel so slowly, they live for an incomprehensible amount of time. While our sun will burn out in a few billion years, red dwarfs will glow for trillions of years. They are the long-term memory of the universe, the last lights that will go out when the cosmos eventually fades. There is a coziness to them, a sense of endurance. They are the quiet, humble majority, keeping the galaxy warm with their low, steady hum, promising to stay lit long after the giants have slept. Eventually, even the brighter stars must reach their end. But for stars like our sun, the end is not a violent explosion, but a gentle, artistic transformation known as a planetary nebula. Despite the name, this has nothing to do with planets. It is the final exhalation of a star. Visualize a star at the end of its life, swelling up and then gently shedding its outer layers into space. It does not rage, it simply lets go. These layers of gas drift outward, glowing in spectral colours of ionized emerald, violet, and gold. They form intricate shapes, rings, hourglasses, butterfly wings, expanding slowly into the silence. At the centre of this jewelled cloud sits the core of the star, now a white dwarf, illuminating the gas from within like a light bulb inside a paper lantern. These are the art galleries of the galaxy. They are ephemeral, lasting only a brief moment in cosmic time, but in that moment, they create the most breathtaking beauty the universe has to offer. It is a vision of death as a creative act, a peaceful release that seeds the void with colour and light. And now, as we drift among these silent lanterns and wandering worlds, we become aware of a profound truth that permeates every light year we have travelled. It is the presence of the great silence. We have been listening, searching, and scanning the heavens for decades, looking for a signal, a beep, a whisper from another civilization. And yet, the galaxy remains quiet. Do not let this silence feel lonely. Instead, visualize it as a peaceful solitude, like the silence of a vast empty library or a snow-covered forest. It is a heavy, blanketed quiet. It implies that we are currently the caretakers of consciousness in this region of space. The silence allows us to hear our own thoughts, to appreciate the rarity of our own voices. It transforms the Milky Way from a crowded metropolis into a personal sanctuary, a vast open cathedral where we can float undisturbed. Maybe others are out there, listening just as we are, and the silence is simply the distance between two thoughts. For now, embrace the quiet. Let it wrap around you, a soft, muting fog that dampens the noise of your life, leaving only the slow, rhythmic breathing of the stars. In this silence, there is no pressure, no expectation, only the deep, resonant peace of simply existing in the dark. Within this profound silence, where the mind rests in the velvet embrace of the void, we begin to sense that emptiness is not truly empty. Just as a quiet room is filled with the subtle currents of air, the silence of the galaxy is threaded with invisible forces. If you could see the universe not just with your eyes, but with a new magnetic sense, the dark spaces between the stars would suddenly light up with intricate glowing webs. These are the galactic magnetic fields. Visualize them as delicate gossamer threads of energy, twisting and turning through the spiral arms like the finest silk spun by a cosmic spider. They follow the curves of the galaxy, tracing the same spiral path as the stars, acting as the nervous system of the Milky Way. These fields are weak, incredibly subtle, yet they are vast, stretching across thousands of light years. They gently guide the interstellar dust, aligning the microscopic grains like compass needles in the dark. Picture yourself floating in a sea of these invisible currents. They are the silent sculptors of the nebulae, pushing and pulling on the gas clouds, helping them resist the crush of gravity just enough to delay the birth of stars, pacing the rhythm of creation. It is a comforting thought that even in the open emptiness, there is a structure, a guiding grain to the ether that holds the dust in formation, a silent magnetic embrace that permeates every cubic inch of the night. Drifting through these magnetic webs, we become aware of a gentle, ceaseless rain falling upon us. We are not talking about water, but about something far more ancient and energetic. These are cosmic rays, the invisible precipitation of the galaxy. Visualize tiny subatomic travelers, protons and atomic nuclei, speeding through the dark at nearly the speed of light. They have been traveling for millions of years, launched by the explosions of dying stars or the violent maws of black holes across the galaxy. To the naked eye, the space around you looks clear, but in this vision, it is sparkling with this microscopic downpour. Imagine them as tiny sparks of fairy dust, showering down upon the solar system, striking the upper atmosphere of Earth and creating cascades of secondary particles. It is a sensation of constant connection. We are physically touched by the history of the galaxy every second. The iron in your blood or the carbon in your cells may be jostled by a particle that began its journey before the dinosaurs evolved. Feel this star rain washing over the protective bubble of our sun, a reminder that the galaxy is not a static picture, but a dynamic, flowing environment where matter and energy are constantly being exchanged across vast distances. As we ride these currents of energy, let us turn our attention back to the motion of our own vessel, the Sun. We have visualized our orbit as a circle around the center, but there is another, more rhythmic motion at play. As the Sun travels its long year around the galaxy, it also bobs up and down, like a carousel horse or a dolphin weaving through the waves of the ocean. This is the galactic oscillation. Visualize the flat, glowing plane of the Milky Way as the surface of a vast luminescent lake. Our Sun does not just skim the surface, it dives below the water, travels through the deep, and then rises back up to breach the surface, climbing high above the disk before falling back down again. This gentle, sinusoidal wave takes millions of years to complete. Right now, we are located slightly above the central plane of the galaxy, drifting in the upper atmosphere of the disk. In the deep past and in the deep future, we pass through the dense mid-plane, where the stars and dust are thickest. This motion gives our solar system a rhythmic exposure to the rest of the galaxy, a slow, cosmic breathing cycle where we rise to see the view, then dive to bathe in the dust and eternal undulation through the river of stars. From our current vantage point slightly above the galactic plane, we can see a specific arrangement of bright stars that dominates our local night sky. We often think the stars are scattered randomly, like salt thrown on a table, but many of the brightest stars we see from Earth belong to a coherent structure known as the Gould Belt. Visualize a ring of fire, a partial hoop of brilliant young blue stars encircling our position. This ring includes many of the most famous constellations: Orion, Scorpius, and Crux. It is a local architectural feature, a tilted ring about 3,000 light-years wide, filled with vibrant star-forming regions. Imagine that we're sitting inside a great cosmic bubble, and the rim of this bubble is lined with these dazzling lights. This structure tells a story of a localized burst of creation near us, perhaps caused by an ancient explosion that swept up the gas in our neighborhood and ignited a ring of new suns. When you look up at the night sky and see the bright pattern of the Milky Way, you're often looking at this specific tilted belt, a local celestial ring road that defines the skyline of our particular corner of the city. Now let us expand our vision beyond the visible light entirely, tuning our eyes to the high-energy spectrum of gamma rays. If we look at the very center of the galaxy, rising perpendicular to the flat disk, we see two colossal phantom structures that were hidden from humanity until very recently. These are the Fermi bubbles. Visualize two gigantic balloons of energy, one expanding upwards from the galactic core and the other extending downwards. They are immense, stretching 25,000 light-years into the void above and below the galaxy. They look like the lobes of an hourglass, or the wings of a giant moth, glowing with a ghostly violet light in our mind's eye. These bubbles are the echoes of a past eruption, a burp from the supermassive black hole at the center, or perhaps the result of a frenzy of starbirth millions of years ago. They are expanding at incredible speeds, blowing a wind of charged particles out into the intergalactic halo. To visualize them is to realize that our galaxy is not just a flat plate, it is a three-dimensional fountain, pumping energy out into the surrounding universe, creating a structure of immense scale that sits silently above and below the stars we know. While these bubbles expand outward, there is something else moving inward, a ghost walking through the walls of our house. We tend to think of the Milky Way as a solid, isolated object, but right now, at this very moment, another galaxy is passing directly through us. This is the Sagittarius Dwarf Spheroidal Galaxy. Visualize a diffuse cloud of stars, a small, ghostly galaxy that has been captured by the Milky Way's gravity. It is not crashing into us with a bang. Space is too empty for that. Instead, it is sliding through the disk of the Milky Way on the opposite side of the glowing core from us. Imagine a phantom walker passing through a crowded room, its stars mingling with ours but never touching. The Milky Way is slowly ripping this visitor apart, pulling long streamers of stars from its body to add to our own halo. This ghost has passed through the Milky Way's disk several times in the past, and each time its gravity has rung the bell of our galaxy, sending ripples through the spiral arms that may have triggered the formation of our own sun. We are living in a merger, a slow-motion consumption of a neighbour that has shaped the very spiral structure we admire today. Amidst this slow dance of gravity and mergers, there are individual stars that have chosen a different path, the path of radical freedom. These are the hypervelocity stars, the escapists of the galaxy. Visualize a star that has wandered too close to the supermassive black hole at the centre. Instead of being eaten, it is caught in a gravitational slingshot, a violent interaction that flings it outward at an unimaginable speed. These stars are moving so fast, millions of miles per hour, that the gravity of the whole galaxy can no longer hold them. Picture a single point of light, racing away from the crowded downtown of the galactic core, piercing through the spiral arms and heading for the dark exit. They are destined to leave the Milky Way entirely, to sail out into the profound emptiness of intergalactic space, never to return. There is a melancholy beauty to them, solitary runners sprinting into the void, carrying the light of the Milky Way out to the lonely spaces between the island universes. They represent the ultimate liberation, breaking the chains of gravity to travel the endless dark alone. As we watch these runners fade into the distance, our gaze drifts back to the disk and settles on a patch of sky that seems devoid of stars entirely. Against the bright diamond dust background of the Southern Cross, there lies a silhouette, a thumbprint of absolute ink. This is the Coalsack Nebula. Visualize a hole in the heavens, a place where the starlight seems to have been erased. Indigenous Australians looked at this darkness and saw not a void, but a creature, the head of a great celestial emu. In reality, it is a cold, dense cloud of dust, floating only 600 light-years away from us. It is so thick that it blocks the light of the stars behind it, creating a perfect shadow. Imagine floating toward this cloud. As you enter it, the dazzling light of the galaxy is cut off. You're wrapped in a cocoon of cold molecular gas. It is one of the quietest places you can imagine, a dark room within the House of Stars. Yet this darkness is not dead. It is waiting. Inside this cold ink, gravity is slowly pulling the dust together. In millions of years, this black patch will ignite with new clusters of stars. For now, it remains a beautiful negative space, a reminder of the power of shadow to define the light. In the vast distances between these dark clouds and bright stars, there exists a network of precise ticking clocks that keep time for the cosmos. These are the pulsars. Visualize a star that has died and collapsed, crushing all its mass into a ball only a few miles wide, a city-sized sphere of neutrons spinning at a dizzying speed. As it spins, it shoots out two beams of intense radiation from its magnetic poles, like the beams of a lighthouse, Because the star is spinning so fast, these beams sweep across the sky hundreds of times a second. Tick, 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 tick. If you could hear them as radio waves, they would sound like a rapid drumbeat, a steady rhythmic thrumming in the silence. These are the metronomes of the Milky Way. They're so precise that they rival our best atomic clocks. Imagine a vast ocean of darkness, dotted with these spinning lighthouses, their beams sweeping through the fog of space, marking the passage of time with unwavering accuracy. They guide us. They are the navigation buoys of the deep, signalling their presence across thousands of light years, a rhythmic heartbeat underlying the stillness of the galaxy. Finally, let us push our journey to the very limit, drifting outward past the Sun, past the local arm, past the Sagittarius arm, until we reach the Cygnus arm, also known as the outer arm. Here, we stand on the precipice, the very edge of the Milky Way's visible disk. Visualize standing on a cliff at the end of the world. Behind you lies the magnificent glowing city of the galaxy, a horizon filled with billions of suns, nebulae and clusters, a sky awash in gold and violet light. But before you, facing outward, there is only the deep. The stars here are sparse, scattered like lonely outposts on a frontier. Looking out, you gaze into the true intergalactic void, the abyss that separates us from Andromeda. It is a drop of millions of light years. The darkness here is total, a velvet curtain that has fallen over the stage. Yet standing on this rim, there is no fear, only a sense of perspective. You're on the shore of the cosmic ocean, looking out at the distant islands of other galaxies, faint smudges in the dark. Feel the cool breeze of the intergalactic medium, the sense of looking off the edge of the map. This is the boundary of our home, the definition of where here ends and the infinite out there begins, a silent border guarded by the last lonely sentinels of the outer rim. Standing on this precipice, gazing out into the bottomless depth of the intergalactic void, we realise that the boundary of the Milky Way is not a sharp line, but a fading mist. If you were to turn your gaze away from the flat disk of the spiral arms and look above and below the galactic plane, you would find that we are not merely contained within a flat wheel. We are encased in a vast, ghostly sphere known as the stellar halo. Visualize a translucent globe of sparse, ancient light that surrounds the entire galaxy like a protective aura. This is the domain of the ancestors. While the spiral arms are crowded with young, boisterous stars and thick clouds of dust, the halo is nearly empty, populated only by the oldest stars in the universe. These are the survivors of the galaxy's turbulent youth, lonely sentinels that travel on long looping orbits, which take them far out into the deep black and then plunge them back through the disk. Drifting here, the sky would be pitch black, punctuated only by these rare, dim embers. It is a place of profound solitude, a silent shell that holds the memory of the galaxy's formation, wrapping the vibrant city within a sphere of quiet, watchful ghosts. As we drift through this spherical halo, we notice that it is not entirely static. There are great shapes moving through the dark, massive accumulations of gas that do not behave like the orderly stars of the disk. These are the high-velocity clouds. Visualize them as gigantic, invisible rainstorms falling from the intergalactic ceiling. One of them, known as the Smith Cloud, is a colossal river of hydrogen gas, millions of times the mass of the Sun, hurtling toward the Milky Way at immense speed. It is a boomerang thrown eons ago that is finally returning. To the eye of a radio telescope, it looks like a comet, streaming a long tail behind it as it plows through the halo's tenuous atmosphere. It is not a weapon, but a gift, a delivery of fresh fuel. When this cloud eventually slams into the disk of our galaxy, it will not cause destruction, but creation. It will compress the gas in the spiral arms, igniting a magnificent firework display of new star birth. It is a reminder that our home is still growing, still feeding, catching the rain of the cosmos to keep its stellar engines burning. Following the trajectory of this infalling gas, we allow our consciousness to sink back down, penetrating the disk, drifting past the spiral arms, and coming to rest in our own immediate neighbourhood. We tend to assume that space is uniform, but the region surrounding our Sun is quite special. We're currently floating inside a colossal cavern known as the local bubble. Visualize a vast, expanding cavity in the interstellar medium, shaped like an hourglass or a peanut. It is a cleared-out pocket of space, hundreds of light-years wide, where the density of gas is incredibly low compared to the rest of the galaxy. It is as if someone blew a bubble in a block of Swiss cheese, and we are floating in the empty air inside the hole. This cavern was carved out millions of years ago by a series of violent supernova explosions. The shockwaves from these dying stars acted like snowplows, pushing the cold, dense gas outward, leaving behind this hot, thin tunnel. As the Sun drifts through this void, we're enjoying a clear view of the universe, protected from the denser, dustier clouds that form the walls of our bubble. Feel the openness of this local space, a clear-cut glade in the galactic forest where the air is thin and the visibility is infinite. In this clear clearing, we can clearly see the nature of the stars around us. We've grown up with a single sun, a solitary golden coin in the sky, leading us to believe this is the standard for the universe. But in reality, being alone is the exception. The majority of the points of light you see are not singletons, but binary star systems. Visualize a cosmic waltz, two great suns locked in an eternal embrace by the invisible rope of gravity. They revolve around a common centre, spinning endlessly in the dark. The combinations are as varied as they are beautiful. Picture a massive sapphire blue giant paired with a small golden dwarf, their colours mixing in the void to create light of a hue we cannot name. If you stood on a planet orbiting such a pair, you would have two shadows. You would see double sunsets, where a red sun dips below the horizon followed by a blue one, painting the sky in gradients of violet and orange. These stars are never apart. They are born together, they live together, and often they die together. It adds a layer of romance to the cold mechanics of space, a universe where companionship is the rule and solitude is the anomaly. Sometimes this closeness between stars becomes intimate and destructive. In certain binary systems, the partners draw so near that they begin to touch, creating the dramatic spectacle of a vampire star. Visualize a scene where a small, dense white dwarf star sits close to a bloated, dying giant. The gravity of the smaller star is so intense that it begins to strip the atmosphere off its larger companion. Picture a stream of glowing plasma being siphoned from the giant, spiralling down like water circling a drain, forming a flat, glowing accretion disk around the vampire star. This disk shines with a fierce, ultraviolet light, hotter than the surface of the sun. The thief star feeds on the lifeblood of its partner, growing heavier and more unstable until it can take no more. This is a relationship of consumption, a celestial transfer of matter that lights up the dark with the energy of 1,000 suns, a slow-motion feast occurring in the silence of the void. Leaving these vampiric dances, we drift toward a solitary object that commands respect through sheer, invisible power. Deep in the star fields, there are the remnants of stars that have collapsed into something far more extreme than a standard neutron star. These are the magnetas. Visualize a star no larger than a city, spinning in the dark, but possessing a magnetic field of terrifying intensity, trillions of times stronger than the Earth's. The air around this object is not empty. The magnetic field is so strong that it distorts the very shape of the atoms nearby, stretching them into thin needles. If you were to drift too close, thousands of miles away, the magnetic force alone would dissolve the chemistry of your body. These stars are silent, brooding monsters, but occasionally the crust of the star cracks under the magnetic pressure. This starquake releases a blast of high-energy gamma rays that can cross the entire galaxy in a heartbeat. To float near a magneta is to be in the presence of the ultimate tension, a small, dense knot of matter holding back a storm of magnetic fury that warps the fabric of reality itself. Seeking tranquility after the tension of the magnetar, we travel to one of the most iconic landscapes in the Milky Way, a place that resembles a fantasy painting brought to life. We drift into the Eagle Nebula to witness the pillars of creation. Visualize 3 towering columns of cold gas and dust, standing like stalagmites in a cave, light years tall. They are not grey or flat. They are illuminated by the ultraviolet brilliance of nearby young stars, glowing with an ethereal halo of gold and blue. These pillars are being eroded, sculpted by the stellar winds like sand dunes in a desert storm. At the very tips of these fingers of mist, tiny knots of gas are holding firm. These are the eggs from which new solar systems are hatching. To look at them is to look at a sculpture in progress, a masterpiece of erosion where the light is carving the dark, revealing the hidden stars buried deep within the stone-coloured clouds. It is a scene of majestic stillness, a cathedral of dust where the architecture is built on the scale of light years. Floating closer to the shadowed regions of these nebulae, we find smaller, more isolated cocoons known as Bok globules. These are the introverts of the star-forming world. Visualize a small, incredibly dense drop of black ink suspended against a background of glowing gas. It looks like a hole punch in the fabric of the nebula. These globules are compact clouds of dust, cut off from the rest of the herd. Inside this dark, cold shell, shielded from the noise and radiation of the outside universe, a star is quietly forming. It is a private womb, a solitary nursery where gravity works in secret. There is a sense of intimacy here, a feeling of hiding away to undergo a transformation. These globules remind us that great things often have humble, quiet beginnings, developing in the dark, protected and unseen until they are ready to shine. We have spoken of stars and gas, but what of the worlds that orbit them? The galaxy is full of planets, and not all of them are made of rock and ice like our own. Deep in the constellation of Cancer, orbiting a neutron star, we find a world that challenges our understanding of value, a diamond planet. Visualize a world twice the size of Earth, but formed in a system rich in carbon and crushed by immense gravity. The heat and pressure here are so intense that the carbon mantle of the planet has crystallized. Imagine a landscape not of dirt or sand, but of pure diamond. Great mountains of translucent crystal rise up to meet a dark sky, their facets catching the starlight and splitting it into a kaleidoscope of rainbows. The ground beneath you is hard and clear, shimmering with an internal fire. It is a planet of supreme luxury and supreme inhospitality, a glittering jewel floating in the dark. It serves as a reminder that the universe is capable of forging materials that we consider precious on scales that render them commonplace, turning entire worlds into treasures that no hand can ever hold. Finally, we seek a place to cool down, to rest from the heat of stars and the pressure of diamonds. We drift toward the Centaurus constellation to find the coldest place in the known universe, the Boomerang Nebula. Visualize a ghostly, bow-tie-shaped cloud of gas expanding rapidly outward. The expansion is driving the temperature down, far below the freezing point of any winter we have ever known. It is only 1 degree above absolute zero, colder than the empty vacuum of space itself. Here, the atoms have almost stopped moving. The stillness is absolute. If you were to float here, you would be in a realm of suspended animation, a deep freeze that preserves the silence perfectly. The gas glows with a faint, ghostly white light, reflecting the dying star at its centre. It is the ultimate sanctuary of calm, a place where the frenetic energy of the galaxy has been dialed down to zero. In this frozen quiet, we find the perfect end to this leg of our journey, resting in the deep, icy breath of the cosmos, suspended in a stillness so profound that time itself seems to freeze along with the light. Leaving the frozen silence of the Boomerang Nebula, where the stillness of atoms is absolute, we allow our minds to thaw gently, drifting toward a vision of deep, enveloping liquidity. The galaxy is not merely a collection of gas and rock, it is also a harbour for water. In the vast catalogue of exoplanets, those worlds orbiting distant stars, there exists a class of planets known as ocean worlds, or Hycean planets. Visualize a sphere suspended in the dark, larger than Earth but smaller than Neptune. It has no continents, no islands, no jagged peaks breaking the surface. It is a perfect, smooth marble of deep azure. The ocean here does not end at a few miles deep. It extends downward for hundreds of miles, a global sea of unfathomable volume. Imagine floating on the surface of this endless water. The horizon is a flat, unbroken line in every direction. The water calm and rhythmic, breathing with the gravity of its parent star. Beneath you lies a world of eternal liquid, a warm, high-pressure womb where life could float in three-dimensional freedom, untethered by the need for ground. The atmosphere above is thick and steamy, trapping the heat, creating a humid, tropical serenity that wraps the entire planet. To visit such a place is to confront the concept of depth, to realize that in the Milky Way, there are reservoirs of water so vast that they could swallow every landmass we have ever known, and still remain smooth, unbroken mirrors reflecting the silent stars. As we rise from this endless ocean, drifting back into the stellar stream, we encounter a family of objects that defy easy categorization, hovering in the twilight between stars and planets. These are the brown dwarfs. Visualize an object that failed to ignite. It gathered mass from the nebula, pulling in gas and dust, growing heavier and denser, but it never reached the critical point needed to start the nuclear fire of a true star. It is a failed star, but do not think of it as dead. Instead, visualize it as a warm, glowing ember. These objects do not shine with the blinding white or yellow of the sun. They glow with a deep, surreal magenta or a bruised purple hue. If you were to float near one, you would not be incinerated. Some of the coolest brown dwarfs, the Y-class, have surface temperatures similar to a hot cup of tea or a human body. You could essentially hover near it and feel a gentle, radiating warmth against your skin, a cosmic radiator humming in the dark. They are the bridge between the gas giants and the burning suns, filling the galaxy with billions of warm, dark, lonely points of light that we can barely see, like cooling coals scattered across a vast velvet floor. Drifting away from the magenta glow of the brown dwarfs, we find ourselves entering a region of soft, scattered light. We have spoken of nebulae that glow with their own heat, but there is another kind, more subtle and ghostly, the reflection nebula. Visualize a cloud of dust that is not hot enough to emit its own light. Instead, it acts as a colossal mirror. A bright blue star sits nearby, and its intense light hits the dust grains, microscopic shards of carbon and iron. The dust scatters this light, turning the cloud into a shimmering ethereal veil of pale blue. The most famous of these is the Witchhead Nebula, or the soft haze surrounding the Pleiades. Picture a fog lit by a street lamp on a winter night, but on a galactic scale. The light here is cool, diffused and gentle on the eyes. It looks like smoke blown into a beam of light, swirling and eddying in slow motion. To float through a reflection nebula is to float through a diamond mist, a place of soft shadows and filtered radiance, where the harsh glare of the stars is softened into a dream-like cerulean haze. Moving through this mist, we begin to understand the mechanics of the spiral arms themselves. We often picture the arms of the Milky Way as solid structures, like the spokes of a wheel, but they are actually transient flowing phenomena known as spiral density waves. Visualize a traffic jam on a highway. The cars slow down, bunching together, creating a dense knot of traffic. But the cars eventually move through the jam and speed up again. The jam itself stays in one place, or moves slowly, while the individual cars flow through it. This is exactly how a spiral arm works. The stars are the cars. As they orbit the galaxy, they enter the invisible density wave, the arm. Gravity slows them down, they bunch up, and the pressure creates new stars lighting up the region. Then, they pass through and continue on their way. You're currently in such a wave, the Orion arm. We're just passing through. Visualize the galaxy not as a solid object, but as a musical rhythm, a standing wave of gravity that organizes the stars into beautiful patterns for a moment before letting them drift on. It is a ripple in a pond that never settles, a constant rotating beat that drives the life cycle of the heavens. Let us now retreat from the mechanics of the galaxy and return to the quiet outskirts of our own home. Far beyond the orbit of Pluto, far beyond the Kuiper Belt, lies the true boundary of our solar system, the Oort cloud. Visualize a gigantic spherical shell made of billions of chunks of ice, rock, and frozen gas. It is not a flat ring, but a bubble that completely encases our sun and planets. It is so distant that the sun appears only as a particularly bright star in the sky, offering no warmth. This is the freezer of the solar system, a vast storage locker where the building blocks of the planets have been kept in deep freeze for 4 billion years. These icy bodies drift in slow, lazy orbits, barely tethered to the sun by the thinnest thread of gravity. It is the realm of the sleeping comets. Occasionally, a passing star will nudge one of these ice mountains, causing it to fall inward toward the sun, becoming a comet with a brilliant tail. But mostly they wait. To be here is to be in the loneliest outpost, the silent shell that separates our family of planets from the open ocean of interstellar space. From this outer shell, we occasionally witness the arrival of silent travellers that do not belong to us. These are the interstellar objects, wanderers like Oumuamua or Comet Borisov. Visualize a piece of driftwood floating in the middle of the ocean. It was not part of the ship, nor does it belong to the land. It has drifted here from a continent thousands of miles away. These objects are debris ejected from other solar systems. They have travelled through the void for millions of years, tumbling silently in the dark before briefly passing through our neighbourhood. Picture a reddish cigar-shaped rock, tumbling end over end, sliding through the silence of our system without stopping. It does not orbit the sun. It carries too much speed. It cuts a hyperbola through the darkness, a brief visitor offering a glimpse of a geology born around a different star before fading back into the night. It reminds us that while the distances are vast, we're not hermetically sealed. The galaxy is full of this debris, a constant invisible exchange of matter between the stars, weaving a subtle connection between distant worlds. As we watch the visitor leave, we turn our gaze back toward the galaxy, but we find that our view is not complete. There is a slice of the universe that is hidden from us, a region known to astronomers as the zone of avoidance. Visualize the Milky Way's disk as a thick, cluttered wall. Because we live inside this disk, looking sideways through it is like trying to see a forest through a thick fog. The dust and stars of our own galaxy block our view of what lies behind them. Approximately 20% of the extragalactic sky is obscured by this great wall of our own making. Behind the core of the Milky Way, there could be massive galaxies, superclusters, or cosmic structures that we simply cannot see. It is the blind spot in our vision, a mystery preserved by our own perspective. Picture vast empires of light and ancient galaxies lurking just behind the curtain of the Milky Way's dust lanes, their light swallowed before it can ever reach our eyes. It teaches us humility, that even with our greatest telescopes, some things remain hidden, veiled by the very beauty of the home we inhabit. Turning our eyes from the hidden to the hollow, we become aware of the texture of the space around us. The interstellar medium is not a smooth fog. It is like Swiss cheese, riddled with vast empty caverns called superbubbles. Visualize a series of supernova explosions happening close together over millions of years. The force of these blasts pushes the gas away, carving out a giant cavity in the arm of the galaxy. We live near the edge of one such structure, the Orion Eridanus superbubble. It is a cavern of space 1,200 light-years across. Inside, the gas is thin and hot. The walls are made of cool, dense shells of hydrogen. Imagine floating inside a giant soap bubble, where the skin of the bubble is where new stars are forming, and the interior is a cleared-out echo chamber of past violences. These bubbles overlap and merge, creating a foaming structure to the galaxy. We are drifting through a tunnel carved by the breath of dying stars, a quiet void protected by walls of compressed gas. Within these bubbles and the gas that surrounds them, the stars are moving, and their movement creates wakes in the interstellar sea. These are the stellar bow shocks. Visualize a boat speeding across a calm lake, pushing a V-shaped wave of water ahead of it. Now, picture a massive star, like the runaway star Zeta Ophiuchi, moving through a cloud of dust at 60,000 miles per hour. The star pushes a wall of gas before it, compressing the material into a glowing arc. In the infrared spectrum, this looks like a crescent moon of fire leading the star through the dark. It is a shock wave, a sonic boom made of light and matter. The star is ploughing the fields of the galaxy, disturbing the stillness. To see this is to see the friction of the cosmos, the physical interaction between a star and its environment. It paints a picture of a galaxy that is thick with substance, where movement leaves a trail, a glowing scar that marks the passage of the giants. Finally, let us pull back, far, far back, until the individual stars, the bubbles, the bow shocks, and the spiral arms all blend together. If you could hover outside the Milky Way, looking down upon it as a whole, what colour would you see? We often see photos enhanced with false colours, neon pinks and electric blues, but the true colour of our home is far more gentle. Visualise a pure, soft white, reminiscent of fine bone china or fresh spring snow just after sunrise. Scientists have analysed the combined light of all the stars in the galaxy and determined that to the human eye, the Milky Way would appear almost entirely white, perhaps with a very faint, creamy yellowish undertone from the older stars in the core. It is the colour of milk, fittingly. It does not scream with colour. It glows with a serene, unified radiance. It is a cosmic latte, a blend of the blue heat of youth and the gold warmth of age, mixing together to create a peaceful, neutral light. This is the lamp that lights our universe. As we drift in this white silence, we realise that for all its chaos and complexity close up, from a distance, our galaxy is a thing of simple, elegant purity, a spiral of pale light turning slowly in the endless dark. Within that creamy, unified radiance of the cosmic latte, where billions of stars blend into a single gentle glow, a profound realization begins to dawn. For centuries we looked up and believed that planets were rare, precious gems, unique accidents of creation. But as we drift closer to the individual points of light that make up this galactic milk, we find that the opposite is true. We're entering the era of the ubiquity of worlds. Visualize the galaxy not just as a collection of burning stars, but as a boundless archipelago of islands. Recent surveys of the heavens have revealed a staggering truth. On average, there is at least one planet for every star in the Milky Way. This means there are more planets than stars. Picture a forest where every single tree supports a nest. As you float through the spiral arms, realize that you are never far from solid ground. Every flicker of light you see is likely the hearth of a solar system, a centre of gravity holding a family of worlds in its embrace. There are planets made of ice, planets made of lava, planets lighter than cork, and planets denser than lead. The galaxy is not an empty void dotted with fire. It is crowded with landscapes, a crowded sky teeming with trillions of hidden horizons, silent shores, and winds sweeping across surfaces that no eye has ever seen. The abundance is overwhelming, transforming the night sky from a pattern of dots into a tapestry of potential homes, a crowded neighbourhood where we have only just begun to knock on the doors. Among this crowded population of worlds, there is a specific type of planet that appears to be the most common citizen of the galaxy, yet it is entirely absent from our own solar system. These are the super-Earths. Visualize a world that sits in the grand middle ground between the size of our Earth and the size of Neptune. It is a rocky terrestrial planet but built on a majestic scale. Imagine standing on the surface of such a world. The horizon would seem further away, the curvature of the planet more subtle. giving the impression of an endless flat plane stretching into infinity. Because of its mass, the gravity here would be stronger, pulling you down with a firm, heavy embrace, perhaps creating a landscape of lower, flatter mountains and sweeping shallow valleys. These worlds might be entirely covered in oceans thousands of miles deep, or they might be rocky fortresses with atmospheres thick enough to crush a submarine. They are the big sisters of Earth, massive and silent. To float above a super-Earth is to witness a version of our own home supercharged, a reminder that nature often prefers to paint on a larger canvas than the one we were given. On many of these distant worlds, the relationship between the planet and its sun is far more intimate and static than our own rhythm of day and night. A vast number of planets in the Milky Way are experiencing a phenomenon known as tidal locking. Visualize a world that has slowed its rotation until it matches its orbit perfectly. It faces its star the way the moon faces the Earth, with one side forever locked in a stare. On one hemisphere, the sun never sets. It is a land of eternal noon, a baking, blinding desert where the shadows never move. On the other hemisphere, the sun never rises. It is a kingdom of eternal ice and darkness, a night that has lasted for billions of years. But between these two extremes lies the twilight zone, or the Terminator line. Visualize a ring of land circling the entire planet where the sun sits forever on the horizon, painting the sky in a perpetual deep orange sunset. Here, the temperature is mild, a constant soothing dusk. Winds would blow constantly from the hot side to the cold side, carrying heat across the twilight belt. It is a world of suspended time, where you could walk forever in the golden hour, caught in a beautiful frozen moment between the light and the dark. In the strange atmospheres of these alien worlds, the weather behaves in ways that would seem like a dream or a hallucination to a terrestrial mind. We're accustomed to rain made of water, but the galaxy offers precipitation of a far more exotic nature. Consider the exoplanet WASP-76b, or simply visualize a world where the chemistry of the clouds is built from metal and stone. On the hot day side of such a planet, the temperature is high enough to vaporize iron. The metal rises as a gas, drifting on high-altitude winds toward the cooler night side. As it crosses the Terminator into the dark, the iron cools, condenses, and falls. Visualize a slow, heavy rainfall of molten iron droplets, glowing red and orange as they streak through the black sky. On other worlds, deep blue in colour, it rains glass, driven sideways by howling winds. On others, deep within the ice giants, it may rain diamonds, glittering gems falling slowly through the slushy mantle. These are not violent storms in this vision. They are majestic displays of chemistry, the galaxy recycling its elements in beautiful, surreal cycles. Picture standing under a shelter on a distant world, listening to the heavy, rhythmic thrum of liquid metal tapping against the roof, a lullaby of industry sung by the weather itself. Drifting away from these exotic surfaces, we pull back to the very edge of a star's influence. Every star creates a bubble of protection against the interstellar medium, and our sun is no exception. We are travelling now to the heliopause. Visualize the point where the wind from the sun, that stream of charged particles rushing outward, finally runs out of steam. It pushes against the thin gas of the galaxy, and the galaxy pushes back. There is a boundary here, a velvet rope in the deep dark, roughly 11 billion miles from Earth. This is the stagnation point, where the solar wind slows, curls, and stops. It is the skin of our solar system. Inside this bubble, we're in the sun's atmosphere. Outside, we're in the open ocean of the Milky Way. Visualize this boundary not as a hard wall, but as a turbulent, frothing region where magnetic fields twist and break. It is the shoreline of our home. Crossing this line, you feel a shift in the current. The noise of the sun fades, replaced by the cool, steady flow of the galactic wind. It is a place of transition, the final frontier where the domestic warmth of our star gives way to the ancient, cold draft of the interstellar void. Drifting just beyond this invisible boundary, moving silently through the pristine darkness, is a tiny metallic object. It is the furthest human-made object from Earth, a solitary traveller known as Voyager 1. Visualize a small, antique probe, looking like a collection of dishes and antennas, tumbling gently in the emptiness. It has been flying for nearly half a century. Its cameras are off, its instruments are powering down, but it carries a cargo of immense significance. Bolted to its side is the golden record. Visualize a disc of gold-plated copper etched with the sounds of Earth, the crash of ocean waves, the song of a whale, the heartbeat of a mother, the word hello in 55 languages. It is a message in a bottle, cast into the longest, deepest ocean imaginable. In the silence of interstellar space, where the nearest star is thousands of years away, this golden disk spins conceptually, a testament to our existence. It is a lonely, beautiful gesture, a hope that one day, eons from now, someone might find it and know that we were here, that we felt, that we dreamed, and that we reached out to touch the dark. As we look past the silhouette of Voyager into the deepest background of the sky, we realize that the dark is not truly dark. If we could see with microwave eyes, the entire sky would be glowing with a faint uniform static. This is the cosmic microwave background. Visualize a wall of fire that has cooled down over 13 billion years until it is just a whisper of heat. This is the afterglow of the Big Bang itself. It is the oldest light in the universe, a snapshot of the cosmos when it was only a baby, a mere 380,000 years old. This light permeates every inch of the Milky Way. It is everywhere, in the space between your fingers, in the empty voids, in the shadow of the moon. It is the backdrop to reality. Visualize it as a low, steady hum, a vibration that underpins all of existence. It is not silence, it is the echo of creation. To bask in this light is to be in touch with the origin of everything, a gentle, ubiquitous reminder that the universe was once hot, dense and unified, and that we are all cooling embers of that initial magnificent fire. Before this background light was released, and after the first stars ignited, there was a period of profound mystery known as the Cosmic Dark Ages. But let us focus on the era inside the galaxy before it was fully formed, the time of the proto-galaxy. Visualize the Milky Way not as the spiral city it is today, but as a shapeless, chaotic fog. Billions of years ago, there were no spiral arms, no disk, no order. There were only vast, cold clouds of hydrogen and helium drifting in the abyss. Slowly, gently, gravity began to pull them together. Picture great streams of gas flowing like rivers in the dark, pooling into a central knot. There were no heavy elements yet. No carbon, no oxygen, no iron. The universe was clean and simple. In this primordial gloom, the first massive stars ignited, flashing like paparazzi bulbs in a dark stadium. They were violet, furious, and short-lived. To visualize this era is to see the galaxy in its embryonic state. A stormy, unformed cloud struggling to find its shape, churning and mixing in the dark before settling into the graceful spinning plate we call home today. In the present day, if we look into the dense ancient crowds of the globular clusters, those balls of old stars, we find a mystery that defies the aging process. These are the blue stragglers. Visualize a nursing home where, sitting among the elderly, you find a teenager, bright-eyed and energetic. This is a blue straggler. In a cluster where every star should be old, red and dim, these stars burn with a fierce hot blue light, masquerading as youth. But they are not young, they are reborn. These stars have found a way to cheat death. In the crowded dance of the cluster, two older stars have spiraled inward and merged, or one has siphoned fuel from another. This injection of fresh hydrogen rejuvenates the star, spinning it up and turning it blue and hot again. They are the vampires of the stellar world, or perhaps the phoenixes, They remind us that in the dense social networks of the stars, interaction can reverse the clock. They shine as beacons of second chances, burning brightly with stolen time, defying the natural order of decay in the quiet suburbs of the galaxy. Finally, we turn our attention to a phenomenon that allows us to watch the history of the galaxy playing out in slow motion, long after the events have finished. These are light echoes. Visualize a star that exploded centuries ago. The flash of light from that explosion raced past Earth long before we were born. But the light didn't just travel in a straight line toward us. It also travelled outward, in all directions, illuminating the dust clouds surrounding the star. Now, years or centuries later, that reflected light finally reaches us. Picture a ripple expanding in a dark pond. We see a ring of light growing larger and larger around the empty spot where the star used to be. It looks like a ghost expanding into the dark. We are watching the reflection of an event that happened in the distant past, echoing off the canyon walls of interstellar space. It is a visual reverb, a way to see the past moving through the present. It creates a sense of profound depth, showing us that light is a traveller, and that the story of a star is retold again and again as its brilliance washes over the dust of the Milky Way, painting the history of its life onto the canvas of the night. As we watch these echoes of light expanding into the darkness, painting the history of the stars onto the canvas of the void, we begin to understand that light is not always a straight traveller. In the deep ocean of the cosmos, gravity acts not just as an anchor, but as a lens. We are entering the realm of gravitational lensing. Visualize a massive object, perhaps a cluster of galaxies or a giant elliptical galaxy, sitting between us and a distant light source. This massive object is so heavy that it curves the fabric of space around it, much like a bowling ball sitting on a soft mattress. When light from a faraway star travels toward us, it does not pass through this depression in a straight line, it follows the curve. It bends, wraps, and flows around the obstacle like water flowing around a stone in a stream. To our eyes, this creates a magnificent distortion. We might see the same distant galaxy appearing 3 or 4 times, magnified and stretched into strange, beautiful arcs. It is nature's own telescope, a cosmic magnifying glass that allows us to see objects that would otherwise be too faint or too distant to perceive. Visualize the universe as a grand hall of mirrors where gravity warps the view, turning the sky into a fluid, shifting masterpiece of liquid light, bending the ancient beams to bring them gently to our eyes. Sometimes, this bending of light achieves a moment of perfect geometric symmetry, known as an Einstein ring. Visualize a moment where a distant galaxy, a massive foreground object, and the Earth align in a perfect straight line. The gravity of the middle object pulls the light of the background galaxy equally from all sides. The result is not a smear or an arc, but a perfect glowing circle of light. Picture a halo of fire suspended in the absolute black, a diamond ring where the diamond has been stretched to encompass the entire band. It is a phenomenon of exquisite precision, a rare alignment in the chaotic drift of the cosmos. To witness an Einstein ring is to witness the elegance of physics, a confirmation that space is flexible, malleable, and capable of forming shapes of pure mathematical beauty. Floating before such a ring, you're looking at a mirage made of starlight, a portal of warped luminescence that frames the deep darkness within its golden loop. While some stars are revealed by these tricks of gravity, others reveal themselves through a rhythmic living pulse. These are the Cepheid variables, the breathing stars of the Milky Way. Most stars, like our Sun, shine with a relatively constant light. But visualize a star that is unstable, a giant that is physically swelling and shrinking. Over the course of days or weeks, this star expands, its outer layers billowing outward, causing its light to dim. Then gravity pulls it back in, compressing the gas and causing it to brighten intensely. Inhale, exhale. Visualize this cycle not as a flicker, but as a slow, deep breath. The star is a lung, respiring in the silence of space. This rhythm is so precise that astronomers use it as a heartbeat to measure the size of the universe. Imagine floating near such a star, feeling the wash of heat and light rise and fall in a soothing hypnotic tempo. It is a cosmic lullaby, a metronome of light that has been ticking since the galaxy was young, regulating the passage of time with its slow, bright heaving. In the company of these breathing giants, there are others that are exhaling with such ferocity that they create art from their own atmospheres. These are the Wolf-Rayet stars. Visualize a massive star 20 times the mass of the Sun nearing the end of its life. It is burning its fuel at a voracious rate, hotter than almost anything else in the galaxy. This intense heat drives a powerful stellar wind, a gale of particles blowing outward at millions of miles per hour. This wind strips the outer layers of the star away, blowing a bubble of gas around itself. These bubbles are not chaotic. They are intricate, glowing spheres of pink, violet, and electric blue. The star sits in the centre, a brilliant violet jewel shrouded in the nebula of its own making. It is a star shedding its skin, revealing the raw nuclear core beneath. To look at a Wolf-Rayet star is to see a tragedy of beauty. It is creating its most magnificent work of art just before it dies, surrounding itself with a glowing shroud of heavy elements that will one day seed the creation of new worlds. Leaving the single stars, we drift toward the grand landscapes where thousands of stars are born together. We find ourselves hovering before the Mystic Mountain in the Carina Nebula. Visualize a landscape of gas and dust that rivals any mountain range on Earth, but on a scale that defies comprehension. Great pillars of cold hydrogen rise up for 3 light years, dark and rugged against the golden background of the nebula. They look like jagged peaks, twisted spires, and craggy cliffs, but they are made of smoke. At the tip of each peak, brilliant young stars are firing off jets of gas, streaming outward like fountains. These jets collide with the surrounding clouds, creating glowing shock waves. It is a chaotic, churning environment, yet from a distance, it appears frozen and majestic. It is a celestial range of peaks and valleys, a place where you could climb forever and never reach the summit, surrounded by the silent golden fog of creation. The mountain is actually being eroded away by the light of the stars above it, a slow-motion crumbling that will take millions of years, leaving behind only the newborn suns. Zooming in on one of these newborn suns, we witness the birth of order from chaos. Surrounding the young star is a flat, spinning structure known as a protoplanetary disk. Visualize a giant vinyl record made of dust and gas, spinning slowly around the central fire. This is the workshop where planets are built. The disk is not a solid sheet. It is marked by dark, concentric rings. These gaps are the tracks where baby planets are moving, sweeping up the dust like cosmic vacuum cleaners. Imagine floating above this spinning plate. It is a place of collisions and accretion, where tiny grains of sand stick together to form pebbles. Pebbles merge into boulders, and boulders smash together to build worlds. The disk glows with a dull infrared heat. It is a busy, dusty construction site, yet it possesses a hypnotic, spinning symmetry. You're witnessing the prehistory of a solar system, the moment when the blueprint of a family of worlds is being drawn in the dust. As we drift outward from the warmth of the central star, across the surface of this dusty disk, we cross an invisible but critical boundary known as the frost line, or the snow line. Visualize a specific distance from the star. In our solar system, it is located roughly between Mars and Jupiter. Inside this line, it is too hot for volatile compounds like water and ammonia to freeze. They remain as gas blown away by the stellar wind. But cross this line, and suddenly, the temperature drops low enough for water to turn into ice. Visualize a sudden transition where the dust grains are no longer bare rock, but are coated in frost. This creates a blizzard of ice crystals in the vacuum. It is here, beyond the snow line, that the giant planets are born. Because ice is solid, there is much more material available to build with. This is why Jupiter and Saturn grew so large. They were born in the snow. To float across the frost line is to move from the dry, rocky inner city to the rich, icy kingdom of the giants, a threshold defined by the simple, quiet freezing of a water molecule. Returning to the mature calmness of our own solar system, we can sometimes see the remnants of this dusty past lingering in the sky. If you're in a very dark place on Earth, just before dawn or just after sunset, you might see a faint triangular glow extending up from the horizon. This is the zodiacal light. Visualize a pyramid of pearly ethereal light, softer than the Milky Way, stretching up into the sky along the path of the sun. This is not atmospheric, it is interplanetary. You're seeing the sunlight reflecting off billions of microscopic dust particles that float in the plane of the solar system. This dust is the debris of comets and colliding asteroids, a thin, glittering sheet that we travel through. It is often called the false dawn. It creates a sensation of connection to the plane of the planets. When you see it, you're seeing the physical disk of our solar system, illuminated by the hidden sun. It is a ghostly reminder that the space between the planets is not empty, but filled with a fine, glittering haze of ancient stone. If we look in the exact opposite direction of the sun, at the darkest point of the night, we might spot an even fainter, more elusive glow known as the Gegenschein. Visualize a subtle oval patch of light, barely brighter than the background darkness. It translates from German as counterglow. It is caused by the same dust that creates the zodiacal light, but here, the dust particles are directly opposite the sun, fully illuminated like millions of tiny full moons. It is the ghost of the solar system. To see it requires the utmost darkness and the utmost patience. It is a shy phenomenon, a whisper of light that disappears if you look at it too directly. It represents the backscatter of our own star's light, returning to us from the deep dark. It feels like a secret, a private luminescence shared only between the sun, the dust, and the observer, hovering silently in the midnight zenith. Finally, as we contemplate the sun and its family of planets and dust, we must remember that our star was not born alone. Like humans, stars are born in families, in the great clusters we visited earlier. But the sun drifts alone now. Somewhere out there, scattered across the spiral arms, are the solar siblings. Visualize the moment of the sun's birth, 4.5 billion years ago. It was part of a cluster of perhaps 1,000 stars, all born from the same nebula, all possessing the exact same chemical fingerprint. For a while, they drifted together, a nursery of siblings. But over eons, the gravity of the galaxy, the passing of spiral arms, and the drift of time have pulled them apart. They have been scattered to the winds. Astronomers are now hunting for them. We have found a few candidates, stars like HD 162826, that share the sun's DNA. Visualize looking at a random star in the night sky and realizing it is your sun's long-lost sister. It glows with the same light. It is made of the same stuff. There is a profound longing in this concept, a galactic search for family. It reminds us that even though our sun seems solitary, it is part of a diaspora, a generation of stars that are now lighting up different corners of the Milky Way, connected by a bond of birth that distance cannot break. Searching for these lost siblings requires a steadfast gaze, an unblinking watchfulness that mirrors one of the most profound efforts in human history. To understand the sheer population of the galaxy, we once decided to stare at a single small patch of the night sky without looking away for years. This is the legacy of the Kepler field. Visualize a specific square of darkness located under the wing of the constellation Cygnus, the Swan. To the naked eye, it is just a quiet corner of the summer sky, sprinkled with a few ordinary stars. But let your mind's eye overlay a grid upon this darkness, a digital net capturing the light of 150,000 stars simultaneously. For 4 years we watched this patch with the intensity of a meditation, never closing the shutter, never turning away. we were waiting for the subtle rhythms of the galaxy to reveal themselves. In this single, motionless stare, we discovered thousands of worlds. Visualize the patience of this vigil, a silent, mechanical eye floating in the cold vacuum, collecting the photons that travelled for centuries just to strike its sensor. It reminds us that the galaxy does not give up its secrets to the casual glance. It rewards the long, steady contemplation, the willingness to sit with the stars in the silence and wait for them to blink. The method by which these secrets are revealed is a phenomenon of delicate shadow, a technique known as the transit. We often imagine discovering planets by seeing them directly, like spotting a ship on the horizon, but in the blinding glare of a star, the planet is lost. Instead, we look for the eclipse. Visualize a star as a roaring, brilliant campfire on a distant hill. Now imagine a moth flying in front of that fire. For a brief second, the light dims, not by much, perhaps only by a fraction of a percent, but it dims. This is the heartbeat of discovery. When a planet crosses the face of its sun, it casts a tiny circular shadow that travels across the star's disk. Dip and return. Visualize this rhythm repeating like clockwork, every 3 days, every month, or every year. The galaxy is filled with these winking lights, a cosmic Morse code where the intervals of darkness tell us the size and speed of the worlds orbiting there. To float in space and watch a transit is to witness a silent silhouette, a world of potential oceans and mountains reduced to a perfect travelling circle of darkness that briefly interrupts the ancient stream of starlight. Among the shadows detected in this stellar survey, we found a class of worlds that completely overturned our understanding of how solar systems are built. These are the hot Jupiters. In our own home, the giant planets, Jupiter and Saturn, keep their distance, orbiting in the cold outer reaches. We assumed this was the law, but the galaxy is wilder than we imagined. Visualize a gas giant, a planet distinctively larger than Jupiter, orbiting its star closer than Mercury orbits the Sun. These are the roasting giants. They whip around their parent stars at breakneck speeds, with years that last only a few days. The proximity is terrifying and beautiful. Visualize the view from the cloud tops of such a world. The star would not be a dot in the sky. It would be a colossal wall of fire filling the entire horizon, dominating the heavens with a blinding, heat-searing presence. The clouds here might be made of vaporized rock or titanium, driven by winds moving faster than sound. These worlds are tidally locked, one side forever roasting in the furnace, the other frozen in shadow. They remind us that our solar system is just one configuration among millions, and that out there, giants can dance on the very edge of the fire. The existence of these roasting giants leads us to a concept that changes the history of our own neighbourhood: planetary migration. We tend to think of planets as static, running on tracks that were laid down at the dawn of time. But planets are wanderers. Visualize the early solar system not as a clockwork mechanism, but as a turbulent ocean. The giant planets, Jupiter and Saturn, did not form where they are today. They moved. Picture Jupiter as a massive ship sailing through the disk of gas and dust, spiralling inward toward the Sun, ploughing through the debris, clearing a path. Then, caught by the gravity of Saturn, it tacked like a sailboat catching the wind, reversing course and migrating outward to the cold dark. This movement is known as the Grand Tack. As these giants moved, they scattered asteroids and comets like a plough pushing snow, reshaping the architecture of the entire system. Feel the weight of this movement, the gravity of a billion worlds shifting, sliding and settling. It suggests that the layout of the night sky is not a fixed monument, but the result of a great chaotic settling, where the giants wandered until they found their balance in the dark. When the giants finally settled, they created invisible pockets of stability in the void, hidden sanctuaries known as Lagrange points. Visualize the gravity of the Sun pulling inward, and the centrifugal force of a planet pulling outward. In 5 specific spots in the orbit, These forces cancel each other out perfectly. It is a gravitational doldrum, a place where the water is still. If you were to park a spacecraft or an asteroid in one of these spots, it would stay there forever, locked in a gentle, stable embrace, moving in perfect synchronization with the planet. Visualize these points as invisible camping grounds in the vast emptiness. L1 sits between the Sun and the Earth, a permanent lookout post. L2 sits behind the Earth, in the quiet shadow where we hide our telescopes. L4 and L5 sit ahead and behind the planet in its orbit. These are the quiet valleys in the gravitational landscape, places of rest where the tug-of-war of the universe resolves into a perfect, silent equilibrium. In the stable valleys ahead of and behind the giant planet Jupiter, this equilibrium has gathered a massive collection of ancient travellers. These are the Trojan asteroids. Visualize two vast swarms of rocks, numbering in the millions, trapped in the L4 and L5 points of Jupiter's orbit. They do not orbit the planet, they orbit the nothingness, the stable point in space, marching in lockstep with the giant world. They are like an honor guard, or entourage, one camp leading the planet by 60 degrees, the other trailing behind by the same distance. These rocks are time capsules, leftovers from the very formation of the solar system, held in suspended animation by the balance of gravity. Imagine floating in the middle of one of these swarms. You're surrounded by silent, dark mountains of rock and ice, tumbling slowly in the void. They have been trapped here for 4 billion years, prisoners of stability. They are the Greek and Trojan camps, celestial reenactors of an ancient war, forever circling the sun in a fixed formation, bound to the king of planets by invisible tethers. Sometimes, however, gravity is not a stabilizing force, but a destructive one. If a moon or a comet ventures too close to a planet, it crosses a fatal invisible line known as the Roche limit. Visualize a moon spiraling inward toward a gas giant. As it gets closer, the gravity pulling on the front of the moon becomes significantly stronger than the gravity pulling on the back. The moon begins to stretch, warping into the shape of a football. The internal stress builds, the rocks grinding and groaning under the tidal force. Then, silently and magnificently, the limit is breached. The moon shatters. It disintegrates, pulled apart by the invisible hands of gravity, dissolving into trillions of tiny fragments. These fragments do not disappear. They spread out, smearing into a flat, shimmering disk around the planet. This is the birth of a ring system. When you look at the rings of Saturn, you're looking at the beautiful wreckage of a moon that wandered too close, a ghost spread out into a circle of ice, a monument to the power of the Roche limit to transform a solid world into a river of dust. Now that we're floating among the debris, let us focus on the most spectacular example of this destruction, the rings of Saturn. From a distance, they look like solid sheets of gold and silver, perfect and unblemished. But as we drift closer, the illusion of solidity vanishes. Visualize a blizzard of ice. The rings are composed of billions of individual particles, ranging from grains of sugar to boulders the size of houses. They are nearly pure water ice, gleaming white in the sunlight. Floating here is like floating in a crowded, chaotic yet strangely orderly river of icebergs. Every particle is a tiny moon on its own orbit. They gently collide, bumping and jostling in silence, breaking apart and reforming. The rings are incredibly thin, in some places only 30 feet thick. Imagine a sheet of paper stretching across a city. That is the scale. As you drift through this glittering expanse, notice the shadows cast by the larger boulders on the finer dust. It is a landscape of high contrast, brilliant white ice against the deep black of Saturn's shadow. It is not a static sculpture. It is a flowing, grinding, shimmering stream of cold light, circling the giant forever. Within this icy flow, there are guardians that maintain the order. These are the shepherd moons. Visualize a gap in the rings, a dark lane where the ice has been cleared away, Running along the edges of this gap are small potato-shaped moons like Prometheus and Pandora. They are the sheepdogs of the ring system. Their gravity interacts with the ring particles, pushing and pulling them, keeping the herd in line. If a particle drifts too far out into the gap, the shepherd moon gives it a gravitational nudge, sending it back into the ring or ejecting it entirely. You can actually see the wake they create, ripples and waves in the ring material, like the wake of a boat in algae. These moons are the architects of the gaps, the reason the rings have sharp, defined edges rather than fading away into a fuzzy mist. They work in eternal silence, their small gravity acting as a chisel, sculpting the rings into the intricate striped masterpiece we see today. Drifting outward from the rings, we come to a world that feels eerily familiar, yet fundamentally alien. This is Saturn's largest moon, Titan. It is the only moon in the solar system with a thick atmosphere, a shroud of nitrogen and methane that hides its surface from view, visualized descending through a dense orange haze. The sky here is not blue, but a deep muddy tangerine colour, thick and heavy. The air pressure is higher than on Earth. If you stood here, you would feel a heavy blanket of atmosphere pressing against you. As you drop below the smog, a strange landscape reveals itself. You see rivers, valleys, and coastlines, but they are carved not by water, but by liquid methane. It is so cold here, hundreds of degrees below zero, that natural gas turns into a liquid. Visualize a lake of pure methane, black and smooth as glass, reflecting the orange sky. It is perfectly still. Because the gravity is low and the air is thick, the waves are small and slow, moving like oil. Rain falls here, but it falls in slow motion, large drops of liquid natural gas drifting down lazily to feed the silent dark seas. It is a mirror image of Earth, distorted by the deep freeze, a familiar cycle of rain and rivers played out with alien chemistry in the dim amber twilight. Leaving the heavy amber twilight of Titan and its silent methane seas, we ascend through the thick orange smog, breaking through the haze to find ourselves back in the clarity of the vacuum. As we drift near the rings of Saturn, our eyes are drawn to a small, glistening sphere that outshines everything around it. This is Enceladus, the brightest object in the solar system. Visualize a moon made of pure, fresh snow. Because its surface is composed of clean ice, it reflects nearly 100% of the sunlight that hits it, glowing with a blinding, pristine whiteness against the black velvet of space. It is a small world, fragile and cold, but as we drift toward its southern pole, the landscape changes. The smooth white ice is slashed by 4 deep parallel fractures known as the tiger stripes. They are stained a pale teal blue, like the heart of a glacier. From these cracks, magnificent geysers of saltwater vapor shoot miles into space. Visualize standing on this frozen surface in absolute silence, watching these fountains of mist erupting lazily in the low gravity. They sparkle in the distant sunlight, turning into fine crystals of ice. This is not just water, it is a signal. Beneath this frozen crust lies a global ocean of warm, salty water, heated by the tidal squeezing of Saturn. As the mist falls back down, it coats the moon in fresh snow, keeping it eternally bright. You're witnessing a world that is exhaling its own secret ocean into the void, creating a ghostly ring of ice crystals that trails behind it as it circles the giant. Turning our gaze from the moon back to the parent planet, we rise high above the plane of the rings, looking down directly at Saturn's North Pole. Here, the golden clouds do not swirl in a spiral, as nature usually dictates. Instead, they form a structure of impossible geometric precision, the hexagon. Visualize a perfect 6-sided shape, wider than 2 Earths, capping the top of the world. It looks artificial, like a giant nut waiting for a cosmic wrench. But it is a natural storm that has been raging for decades, perhaps centuries. The sides of the hexagon are straight, defined by jet streams moving at hundreds of miles per hour. Within this rigid geometry, smaller storms swirl and dance, but the outer walls remain fixed, a fortress of wind. The colour here shifts with the seasons, fading from a summer gold to a winter azure. It is a mesmerising sight, a reminder that in the fluid dynamics of massive atmospheres, chaos can self-organise into order. To float above this pole is to stare into a kaleidoscope of gas, watching a mathematical theorem played out on a planetary scale, spinning slowly, silently, and perfectly in the cold light of the distant sun. We now leave the kingdom of Saturn behind. The rings fade to a thin line, then a dot, as we drift deeper into the darkness, crossing 1 billion miles of empty space to reach the first of the ice giants, Uranus. Visualize a world that challenges your sense of orientation. While every other planet spins like a top, Uranus rolls like a ball. It is tipped entirely on its side, its equator running vertically, its poles pointing directly at the sun. As you approach, the colour is a soft, pale cyan, a serene and sleepy blue caused by methane in the atmosphere absorbing the red light. Because of this extreme tilt, the seasons here are extreme and long. For 42 Earth years, the North Pole is bathed in constant sunlight, a day that lasts half a lifetime. Then, for the next 42 years, it is plunged into total pitch-black darkness. Imagine floating above the cloud tops during the solstice. You're looking at a bullseye pattern of clouds, circling the pole which faces the sun directly. It feels unbalanced, dizzying, as if the planet has fallen over and cannot get up, rolling endlessly along its orbital track. It is a lonely, cold, and quiet world. A pale blue marble lost in a slumber that lasts for decades. But beneath those sleepy pale blue clouds, deep within the crushed interior of the planet, a process of exquisite value is taking place. We are entering the realm of diamond rain. Visualize diving down through the thick atmosphere of Uranus and its twin, Neptune. The pressure mounts rapidly, crushing gas into liquid and liquid into a slush of hot, dense ices, water, ammonia, and methane. Deep in this mantle, thousands of miles down, the pressure becomes so intense that it splits the methane molecules apart. The carbon atoms are squeezed together, crystallizing instantly. Picture diamonds, not as small stones, but as massive gems forming in the dark slush. They are heavier than the surrounding fluid, so they begin to fall. Visualize a rainstorm of diamonds, a slow, glittering shower of wealth sinking toward the core. They accumulate there, forming layers of diamond thousands of miles thick surrounding the rocky heart of the planet. It is a vision of hidden extravagance, a treasure trove buried under layers of freezing gas, where the sky rains jewels in the crushing dark of the planetary depths. Leaving the rolling cyan world, we drift further outward to the windswept outpost of the solar system, the deep blue giant Neptune. Visualize a colour so deep, so vivid, it looks like the ocean at midnight. This is not the pale blue of Uranus, this is a rich, royal azure. Despite being so far from the sun, where the sunlight is 30 times fainter than on Earth, this planet is alive with energy. It is the windiest world we know. Visualize bands of white clouds casting shadows on the blue layer below, racing across the face of the planet at supersonic speeds, 1,200 miles per hour. The sound of this wind would be deafening, but in the vacuum, it is silent. Floating in the atmosphere, you would see the Great Dark Spot, a storm the size of Earth, a swirling vortex of indigo swirling in the Cobalt Sea. It appears and disappears over the years, a phantom bruise on the planet's skin. The cold here is biting, near absolute, yet the planet radiates more heat than it receives from the sun, a mysterious internal fire that churns the atmosphere into these violent, beautiful ribbons of speed. Orbiting this windy giant is a moon that behaves like a captured rebel. This is Triton, the only large moon in the solar system that orbits in the opposite direction of its planet's rotation. Visualize a desolate, frozen landscape that looks like the skin of a cantaloupe. The surface is rugged, textured with pits and ridges of icy melon terrain. It is made of nitrogen ice, frozen so hard it is like rock. But despite the temperature being close to absolute zero, this world is geologically alive. As you drift over the southern polar cap, you see dark streaks painted across the pinkish ice. These are the tracks of cryovolcanoes. Visualize a geyser erupting, but instead of fire and lava, it spews nitrogen gas and dark dust. The plume rises straight up in the thin atmosphere for 5 miles, then hits a ceiling of wind and is blown sideways, creating a long black streak like smoke from a factory chimney. These plumes are silent sentinels on a world that is slowly spiraling inward. Triton is doomed. Eons from now, Neptune's gravity will pull it apart, but for now it spins backwards, defying the flow, painting its own surface with the dark dust of its frozen breath. Beyond the orbit of Neptune, we cross a major threshold. We are leaving the realm of the planets and entering the attic of the solar system, the vast, scattered debris field known as the Kuiper Belt. Visualize a vast, donut-shaped ring of darkness. It is immense, stretching for billions of miles. Here, the sun is just a particularly bright star, a pinprick of light that offers no heat. Floating in this expanse are millions of icy bodies, remnants from the dawn of creation. They are the leftovers, the bricks that were never used to build a planet. They are dark reddish-brown rocks, coated in organic compounds called tholins, created by eons of exposure to ultraviolet light. It is quiet here. The distance between objects is vast. You could fly for years and never see one. It feels ancient, a preserved museum of the early solar system. Drifting through the Kuiper Belt is like drifting through a ghost town, where the silent, frozen ruins of the past tumble slowly in the dark, waiting for a visitor that never comes. In the heart of this dark belt reigns the king of the Kuiper Belt, the world we once called the 9th planet, Pluto. Visualize a world smaller than our moon, but possessed of a complex beating heart. The most prominent feature on its surface is a vast heart-shaped plain of white ice, known as Sputnik Planitia. But this is not water ice. It is frozen nitrogen, and it is moving. Visualize a glacier, but one that flows not with the crushing weight of rock, but with the gentle consistency of toothpaste or warm wax. Because Pluto has a small amount of internal heat, this nitrogen ice churns slowly, bubbling up in cells like oatmeal on a stove, erasing craters and smoothing the surface. To stand here would be to stand on a living world. The skies are hazy blue, layered with thin smog. The mountains are made of water ice, floating like icebergs in the denser nitrogen sea. It is a dynamic, beautiful landscape painted in hues of cream, charcoal and deep red. A world that refuses to be dead despite the freezing isolation of the outer rim. Dancing with Pluto is its partner, a moon so large compared to its parent that they are essentially a double planet system. This is Charon. Visualize a grey, battered world, forever locked in a face-to-face stare with Pluto. They spin around a point in empty space between them, a gravitational waltz that never ends. Charon has a distinctive, sinister feature. Its north pole is stained a deep blood red. This is the Mordor macula. It is rust, formed from methane escaping Pluto's atmosphere, freezing onto Charon's pole and being baked by the sun into red tholins. But the most breathtaking feature is the Great Canyon that slices across the moon's equator. Visualize a chasm 4 times deeper than the Grand Canyon, stretching for 1,000 miles. It looks as if the moon's crust simply split open, revealing the abyss beneath. Standing on the edge of this cliff, looking out over the grey expanse toward the red pole, with Pluto hanging motionless in the sky, you feel the profound stillness of the binary dance. 2 frozen lovers holding hands in the dark. Drifting further out into the scattered disk, we encounter one of the strangest shapes in the solar system, the dwarf planet Haumea. Visualize a world that does not look like a sphere. but like a smooth, polished river stone or a rugby ball. It is an ellipsoid, stretched out by its own speed. Haumea spins incredibly fast, completing a full day in less than 4 hours. This dizzying rotation has pulled the planet into an egg shape. If you were to stand on its equator, you would feel significantly lighter than at the poles, as the centrifugal force tries to throw you off into space. The surface is dazzlingly bright, covered in crystalline water ice, almost as reflective as snow. And circling this spinning egg is a delicate thin ring. Visualize a faint hoop of ice particles shimmering faintly, girdling the equator of this tumbling stone. It is a kinetic sculpture, a world defined by its speed, whirling wildly in the slow, sleepy darkness of the outer belt, a frantic dancer on the edge of the known map. From the dizzying spin of that distant, icy stone, we finally let go of the outer rim. We stop moving. We stop searching. We allow ourselves to simply float in the center of the total perspective we have gathered. We have traveled light years, visited diamond rains and dark rifts, ancient clusters and newborn suns. But the final wonder, the one that binds all the others together, is not a place you can visit with a spaceship. It is a realization that collapses the distance between you and the dark. Consider the atoms that make up your hands, resting now on the bedsheets. Consider the oxygen filling your lungs with every slow breath. Consider the iron drifting in your blood, carrying life to your sleeping mind. Every single one of these atoms was forged in the nuclear hearts of the stars we have just visited. The calcium in your bones was created in the red giants. The gold in your ring was fused in the collision of neutron stars. You're not merely an observer looking up at the Milky Way. You are the Milky Way. You are a piece of the galaxy that has cooled down, gathered together, and awakened to look back at itself. There is no separation. The iron in your blood is the same iron that rains down on the night side of distant exoplanets. The carbon in your mind is the same carbon drifting in the quiet nebulae. You are the universe experiencing itself, a consciousness born from stardust, momentarily shaped into a human form, lying safely in a quiet room on a small blue world. This is the ultimate comfort. You belong here. You're not a stranger in the night. You're the night's own child. The vastness above is not empty space. It is your ancestral home, a sprawling, glittering family tree that stretches across 100,000 light years. When you look up, you're looking into a mirror. When you close your eyes, you are returning the stardust to a state of rest, quieting the galaxy within you, syncing your heartbeat with the slow, rhythmic rotation of the spiral arms. You are home. And now the journey begins to slow. The great spiral arms, the glowing nebulae, and the spinning worlds begin to fade, retreating gently into the velvet background of your mind. We drift downward, softly, like a leaf falling through the heavy air of a summer night. We float past the moon, past the clouds, descending back toward the warm, familiar gravity of the Earth. The vast distances contract. The light of the billion stars dims to a soft, protective glimmer. You are returning to your sanctuary. Feel the weight of your body sinking deeper into the mattress, heavy and loose. The journey is over. There is nothing left to see, nothing left to learn, nothing left to do. The universe is turning slowly, silently, and safely, without you needing to watch it. It will be there when you wake, but for now, it is time to let the darkness wrap around you like a soft, heavy quilt. Your breathing is slow and deep, a rhythm as steady as the tides. The silence of the room merges with the silence of the void, a deep, resonant peace that fills every corner of your mind. Let the images of the stars dissolve into feelings of warmth, of heaviness, of total relaxation. You're drifting on the surface of a dark, calm ocean, supported by the depth of the night. Every muscle is asleep. Every thought is fading into a whisper. The stillness is absolute. You're safe, your stardust at rest. And now, 101 wonders are resting with you. Sleep now, Good night.